This is part 2 of how to build a time attack cage. My name is Gabe, and this is my car. It's a 2000 Evo 6 Tommy Mackin Edition RS. I lived in Japan for 4 years and decided I wanted to bring this car back with me. I'm an Evo guy. This is the 4th one I've owned. So after being denied my show and display exemption, I decided to bring it under the racing exemption. There's permanent and temporary, so I went with the permanent. The only downside to that was that it wouldn't be able to be street legal or registered, so it's not street legal, but I was able to get it into the country legally with a letter from Mitsubishi stating that it was built for racing, and I sent that to the EPA with my application for the permanent racing exemption. And with that, I was able to get exempt from any DOT regulations, so I did not have to change anything on the car, bringing it back with me to get it through customs. And that's how I got this car back to the States legally. It's just not registered or street legal, so it is a track-only car.
We move on to the rear braces. Now this does not require any kind of extensive fabrication. In fact, they're extremely simple. So section 4.6.11 of GTA CCR says there must be at least 2 rear braces extending from the main hoop rearward to the point where they mount to the chassis. Now they must have at least 30 degrees between the main hoop and the point where they mount, and they may be in a plane. When viewed from the top, the plane must be no less than 75 degrees, no more than 105 degrees. So when you're looking down, they can have no more of a swing area or an angle to them from the point where they attach to the main hoop. So you can use an X brace, which we're not going to do on this one, which can use 2 separate tubes in a diagonal. And they must be within 6 inches from the top of the main hoop. Now I rarely ever run any down the side of the main hoop, but it is common to see that design. So I'm going to try and keep within 90 degrees exactly. And I'm going to measure from the lowest point on that mounting plate to ensure that I have enough tube. And the lowest point to the top of the main hoop looks like about 42 inches. So I'm going to cut 2 separate tubes at 42 inches each, and we're going to notch them out, stick them in, and then toss in the diagonal. So one important thing to remember when installing the rear braces is to make sure that the section that you have above here is easily accessed with the welder, because remember, you can't drop the cage anymore with the rear braces in here. And since we already permanently welded it to the rest of the chassis, we need to make sure that we can access it with the torch or even the MIG, which I don't like to break precedent and weld the rest of the cage with the MIG when all of it's been welded with a TIG up to this point. So I'm going to make sure that it's easily accessible. Now for the base of it, I just used the MIG. And I'm going to toss a pretty decent tack in here to hold it in place, and that'll give me a chance to kind of worm it around and better place it in a moment. Alright, so we should be good to go on this tube. Take a look here, make sure that there's no significant gaps or anything serious. All of it is very accessible with the TIG. And in a moment I'll take a measure and make sure that we're at the correct angle, and that's when we'll set it up to get the notches. But for right now it's tacked, it's in place. I'm going to get the other side in real quick. Alright, number 2 set up in place. We'll just drop a tack down on here again, just like the other side. Awesome. So now we got a little bit of wiggle room here. We can set these up, get them tacked in place, and then we'll cut and throw in the diagonal to get in here shortly thereafter. So let's get this cracking. Alrighty, let's get down on this rear brace. This final piece for the rear section here is the diagonal. Now, of course, it has to start over in the bottom left and end above the driver's head, top right. So that's where we're measuring from. And it looks like 51.5 inches. So I'm going to go cut a 51.5 inch piece, notch both sides here, throw it up in there, and then the rear section will be done. Alrighty. Tube cut, set. And since I only have one hand free right now, I have to hold this up here. I'm going to use the MIG to drop a little tack on here. And that should hold it in place while I get the TIG out. Let's check a fit real quick on it. Looks like my notches stayed in there quite well. So, all I gotta do is drop a few welds on it, and this whole rear section is complete. It's time to box in the rocker boxes. So I'm just gonna take a measurement here. It looks like 2.5 inches at the widest spot. Looks like about 4.5 inches tall. That should be the same on both front and rear. 4.5, 2.5. So I'm gonna go get the steel cut out for this. Now remember, we do have a taper, or we have an angle of the rocker box, so we're gonna have to actually end up cutting all of that out. And I'll show you how to do that really quick. It's very easy to do. Just simply mark it out and cut. So let me get these cut up and ready, and then we'll get back to getting these welded in. Alright, so these don't require any kind of fancy cutting, so I'm just going to go kind of assembly line style here. So achieving the correct angle on this is actually kind of a breeze. Basically what I do is I'll hold the piece of sheet metal here. I'm going to hold it completely straight, and I'm going to keep this edge in line with the rocker box itself. Now, when pressed up against the lower section here, I can see the gap that I have up top here. So what I'm basically going to do is translate that and mark out, which in this case is about 1/2 inch, and mark that out on the bottom side on the inside. So when we take this line here and run from the mark to the corner, I know exactly how much I have to cut out. And then we'll come back in here and place this again, and then we'll cut out our notch and get this angle down here so that we can actually set our height correctly and make the rocker box side here move around this hump in the sheet metal here. Okay, so it is safe to assume that both pieces are going to be exactly the same because they're servicing on both sides. So I'm going to make quick time out of this and stack the two of them together. Clamp that down. Do a double check on the edging here, make sure everything's good. We're going to cut all this off, two pieces at the same time. Alright, we're actually pretty close on that one. Leaves enough with the edges here that we can fill all that in. So, I'm going to take a Sharpie here. Alright, pretty decent fit here. So what I'm going to do is trace out this little hump section here that has to get cut out in order for the rocker box to actually get to the correct height here. So that should be enough. Just this notch should be enough to get it to sit down correctly. So with that little hump notched out of there, we'll get this as closely lined up as possible. It's actually a little tricky because we're just a tiny bit shy of mating edge to edge after grinding, but shouldn't be that big of a deal. just remember when you're welding thicker steel to thinner steel, such as a 1/8" rocker box panel to a little tin chassis plate here, stitch welding is a good technique there to ensure that when the puddle builds up on the heavier gauge, you can kind of push the puddle or move it down into the sheet metal and you can watch it penetrate. As soon as that happens, move on and let off and keep stitching. Now the rear section doesn't have that little hump in it, but I did have to take just a little bit here and create this little notch to go around the contour of the floor pan. So it fits beautifully. And I'm going to line this one up, drop a couple tacks of course, then we'll check it again. Alright, looks like we're good to go on this one. Just gonna watch my electrical here. Alright, so the position of the rocker box here is right over that hole. So I usually just take a slug that is cut out from the hole saw. And we did the dimple dies for the rocker boxes, and I'm just gonna stick it right over that hole. Lay down a tack or two on it. Alright, now we can fill all that in. So let's move on to the front here. These are actually pre-measured and cut them. They sit at about 5 inches tall, as opposed to the 4.5 in the rear. So since I can't really get around to the back side and work, I'm just going to trace this line, and that'll give me my angle. Now if you notice here, there's a hole right through the middle of that, and I don't want to really fill that in or slug that one. So what I'm actually going to do is just kind of go around it. And I'll place the panel right about where I want it to go. We'll have just a little bit of this little angle on it here, but I need to trace out the little hump in the floor, and this is definitely going to have to be trimmed back just a little bit. I already know that, in order to get this to drop down to the point where it's going to be, because I don't need to fill in that giant gap. And then we'll cut a piece for the top here, a little triangular section, and we'll weld all that in. Now, since it wasn't planned obviously in the beginning for this way, I had to take the seam sealer back a little bit and get rid of the paint that was on there. So now we can tack this in. So just this corner piece to get it filled in here, I'm just going to take some of my flat stock and I'm going to kind of loosely kind of eyeball this here, about the size it needs to be. So from about right there to this corner here, that should be pretty close. It's going to have to take a little bit of hammering and tweaking to get it in there, but you know, somewhere close, cut that off, stick it in there, weld it up, we'll be done. Alright, pretty decent fit. Let's buzz this guy on here real quick. Sometimes you gotta take the hammer to this to kind of tap it down a little bit, which I'm gonna have to do there. Which I'm gonna finish this up, get it all welded in, and then we move on to the best part, or one of my favorite parts about the build, and that's the gussets. So let me get this finished up and we'll move right along. Now, windshields don't always cooperate. In fact, unfortunately, this one suffered a casualty with the blade popping itself in there. The pressure of it just getting in there with the original sealer on there literally just sent the windshield spidered. So I've got it all cut out up top and around the edges here, and all I gotta do now is pull the whole hood, the wiper cowl, the wipers, all that off, and then we'll get the whole windshield out of here. Yeah, I'm absolutely not a windshield specialist, and as such, I'm not even going to put the new one in. I'm going to call somebody in, and they'll come in with a replacement, install it, and all the rest of that good stuff. So now I just got to get all this glass cleaned up. The simplest explanation for gussets is this. The roll cage is permanently attached or mounted, if it's a bolting cage, to the floor. The floor is now stabilized. The floor is now braced. So the floor or the base of the chassis has a difficult time distorting or flexing. But the upper section of the chassis or the body can still flex and distort independently of the rest of the chassis. So to give the ultimate strength and durability under load and during racing, we gusset the top section of the cage to the top section of the body. This ties it into the entire rest of the car. Now, gussets are very, very simple. They typically exist or are constructed of flat sheets of steel. And most commonly, you see a lot of holes popped into them, and the holes are beveled and recessed. Now, as we explained before with the dimple dies, the purpose is to lighten the metal and not weaken it. So when you put a hole in it, you have taken some weight out of it. And going back and dimpling it, we'll put a beveled edge on it, which will strengthen the metal back up. So first we need to figure out how much metal we need or what size it needs to be. So with the windshield out, we can go in here and measure. Now, I'm going to run it from the top of the windshield here to right about where the bend needs to go. So normally you can run it as high as you want or as low as you want, and you can wrap the whole thing if you really felt so inclined to do, but the simplest method and the least amount of metal is what I'm really looking to do. So I'll take a measurement. Looks like to about the beginning of that bend, I'm going to give it just a little bit of wrap on it for a little bit of aesthetic appeal. Looks like I got a 17.5 inch piece. And from the inside, looks like I can get away with a 2.5 inch wide by 17.5 inches long. I already have this cut. So I'm going to stick it in here. And you notice it's going to have to flex just a little bit, and that'll look pretty cool actually. So with it verified this is a good length and whatnot, we'll have to do a little bit of trimming, but we can get over and start measuring and cutting the holes, getting it ready for the dimples. Measuring our spacing really couldn't be simpler. First we're going to start from the inside to the outside. And at 17.5 inches, half is 8 3/4 inches. So I'm going to square this off. That's my center line. So it's really up to you how much spacing or how many dimple dies or how many holes you really want to do. So in this case, I know I can comfortably fit 4 in here, give the ultimate strength, lots of weight reduction, 4 holes ought to do the trick. So the spacing that I'm going to have on there is mostly toward the center of it, because at the bottom of it I have I'm going to brand this cage obviously via the gussets, and the little MP tag is going to stick at the bottom of it. And the top of it's not really going to be seen all that much, and there's going to have to be some trimming anyway to go at the top of it to form fit into that section of the windshield as high as I have it stuffed up there. So 4 holes evenly spaced apart. I already know my dimensions on here. I want 1 1/4 inch spacing between the outsides of the holes, or at least the section that I give to it, and then I want 2 1/4 inches of spacing, or 2 1/4 inch squares that the dimple dies will center and fit in. So we'll measure each of these up. square all those off. Now you can sit here and measure all of this out evenly, get the centers of it, but nice little trick here. Just make an X from one corner to the other. So this is the spacing of our holes. These are the centers of it. I'm going to do a pilot hole in each one of them, make it a little bit easier when I feed the hole saw in there. Now, one problem that you often end up with when you're using a hole saw is sometimes if you don't have anything to back it or hold the pilot bit straight, the hole will kind of tend to wobble. So if you have a hole that's kind of, wobbled out or stretched out or whatever the case is, it makes a really crappy looking gusset. So I'm going to ensure that the pilot bit does not move. So I'm going to start by piloting the hole, drilling a smaller hole, and then I'm going to send it into these blocks of wood. Now the blocks of wood will hold the pilot still while I drill out the rest of it, and that makes a nice, almost perfectly fit, even hole. There's our first panel. So I'm going to take a grinder to this and deburr it just a little bit before we go into send it into the dimples, and I'm also going to chase it down with the file, and that makes the holes nice and smooth and deburrs them completely. So take care of that real quick. The door gussets are actually going to be pretty easy to do as well. They just need a single straight strip. It's going to be a little bit wider, and this time I'm going to use a larger hole. I'm going to use the 1 3/4 dimple die instead of the 1 1/4. So that's going to give a lot of weight reduction on this one panel as well. So you can go all the way down to the bottom if you really prefer to, or you can go all the way to the top, or you can gusset these things anywhere you want. But again, for the purpose of weight reduction, the minimal amount of metal with the most amount of effect on it is exactly what I'm after. So I'm only going to start from about the top here where I can access it with the welder to about, same thing again, about the point of this bend where it meets. So looks like I'll have about a 16-inch piece is about what I can get. So I'm going to pull back the weather stripping here, the door seal. And I'm going to look on the inside, just past where it mounts up. Take a measurement there. Let's see, I can get away with about half of that tube covers. Be about a 4-inch piece. So 16 inches long, 4 inches wide, 1 3/4 hole. Let's get cutting. So I decided I'm not going to brand the rear pieces. I think the 2 that I have up front and then my other normal spots should be enough. So this says just straight even spacing all the way across. Build is a taco gusset that will mirror this gusset over the top here, and we'll brace this upper X-brace section in here. So all we need to know is how high it is and how wide it is so that we have an identical size up top. Now we will need to add in the circumference or half the circumference of a 1.5-inch tube because we're going to wrap it around the top so that the back side is also matches the front side of it. But since we have no tube up top here, we're going to just wrap it around and create what they call the taco. So in order to do that, we'll measure our height, which is 5 inches, and our width is going to be about 9 inches. So 5 by 9, let's grab some of that 18 gauge sheet metal, draw all this out and translate it onto there, wrap it up, and then we got our gusset. So we got a nice piece of 18 gauge here that we're going to use to make the taco gusset. Now, it is already cut at 9 inches wide, and we have more than enough in length here that we're going to end up having to cut out here. We know it needs to be 5 inches tall And to mirror it, it's going to be another 5 inches on the other side, so we'll need at least 10 inches of it. But we also have to wrap the top of it to make the taco gusset. Now the top of it is going to be half the diameter or half the circumference of the tube and half the diameter width. So if you take 1.5 inch tube or 1.5 inch circle, you end up with a 4.71 and a whole lot of other numbers on top of that. We're going to take 4.71, divide that by 2, and you get roughly 2 3/8 of an inch. So we're going to take 5 inches plus 2 3/8 for the circumference plus the other 5 inches. So let's cut all this out real quick. Let's start with our 5 inches. And then we're going to add 2 3/8 of an inch. That's half the circumference. So 2 3/8. And then we're going to add another 5 inches on top of that. That'll get us to about right here. I'm going to use my square to make my lines. There's one. There's another. And there's one more. So in order to get the triangle design that we have on here, we're going to need to know what half of our 9 inches is. It's going to be 4.5 inches to the center. Make sure that comes out the same on both sides. 4.5 inches. So now we'll run a line from the edge of the section that it's cut in to the center. Same thing on the other side. Line from the edge to the center. Now this side also must have a matching dimple. So we'll just run a center line here. And then in the center of that is 2.5 inches, which is half of 5. So these 2 points are the points where we're going to pop our holes and put our dimple die in. Now, that's about as easy as it gets for cutting out a taco gusset or to mark it out. So now we're just going to get strong and grab some tin snips and cut this out. Okay, with that cut out, we need to make a line that represents the halfway point on this, so when we stick it up against the tube later on down the road, we'll be able to easily identify where that sits at. Now, normally you can just take a marker, but I'm actually going to use my metal scribe, make it a little bit easier to see. But half of 2 3/8 is 1 3/16 of an inch. So we're going to mark it there. And we're going to mark it there. Take my scribe, placed on those 2 marks. Voila. Now I'll be able to see this later and easily be able to identify where the center of it is, and then be able to bend it around the tube when the time comes, because right now we have to put the holes in it and then pop the dimples into it. So I'm going to cut these holes out real quick, and then we'll run over the dimple dies, or run over the press and dimple everything out. So now we're going to turn this gusset into the taco gusset. So I just took some spare steel, some DOM that I have laying around. It's a little 1.5" variety, and use it to mark out and clamp to my center line here. And this is kind of tricky if you don't have a press. Just take it on the edge of something and start rolling it. You definitely need it to be as tight as possible. And you want to try and make it as even as possible.
pretty useful trick here if you can't get it to form quite right. You just place it here in the vise and between a couple of boards and clamp it around the tube. That should fit just right now.
Well, I've got it set up in place. I've got it leveled out, matches the other one, except for notice a few of these spots here, just the way that we measured it and how it sits inside the cage and whatnot. It does overhang the bottom gusset, and it covers more than half the tube over here. And, you know, I'm gonna take a few minutes and try and straighten this up a little bit, make it look a little bit better. It's just kind of ugly at the moment where I have it fitted, so I'm just gonna take a straight edge here. And I'm going to mark this out where it needs to be trimmed. That's a bit better. So I'm going to go and trace the back side of this, and then we'll go cut all this off. I'm going to make sure I label which side is which.
I'm just trimming this off a little bit. Now, when you get to sections of an edge right there, you're going to get these little buggers right here called meat hooks. And these are ridiculously sharp, so make sure that you pick them up off the floor and get them out of the way. I mean, you'll learn your lesson the minute you step on just one. And man, I mean, it's it's almost guaranteed stitches every time, so definitely take care of your meat hooks.
Alright, round two. Well, I can see now that's already much better. That's a great fit. So, I'm going to break out the welder, put a few tacks down on this, and we'll go to straighten it out and get it all set up and weld it all in. Alright, now for the piece de resistance. A little MP tag, because I love to brand all of my work. Let it be known that this is a part that nobody else can have unless you come here. So, try and get it as even as possible. Okay, so now for the gussets. The body gussets, I guess, is what a lot of people would call them. Some people call this like an A pillar, a B pillar gusset, a door gusset, a body gusset. There's a dozen different names for them. So, one key element here, very, very important, is make sure you get all of the paint off. Because unfortunately, the body is not made of weld-proof paint. So, wherever your spots are that you're going to end up welding to, make sure that there's no paint there. To ease this right along, I have my pony clamps just kind of set up in a relative position to the rest of the body. So, I'm just going to take my MIG here and put a couple tacks down on it, and then we'll go to the other side and adjust.
Okay, so let's move on to the front gussets. I have my placement in mind, and the panel's going to have to tweak just a little bit, which is actually kind of cool when they do that. You get this nice little swooping kind of transition. Makes for a really cool looking gusset. So I'm going to place this in here. Toss a couple of clamps down here, just these little pointy clamps. Sometimes they hold. And I'll look up in there, you can see all this paint and everything that needs to come off. And you can also see the fitment of the gusset, how well you'll actually be able to weld it and all the rest of that stuff inside of there. Now buzzing it onto the chassis, of course, needs to be done with the MIG, and I'm going to use the TIG to get it to the roll cage. So I can see about where it needs to land. Now the owner did a fantastic job at flocking this dashboard, and I have no intentions whatsoever of screwing it up. So during the process of removing all the paint and getting it welded and whatnot, we're going to have to cover it just to make sure that it doesn't get messed up. Cover with plastic for the little particles. Now I'm going to wrap it up in a fire blanket. To be extra safe, I'm going to wrap the fire blanket up more on this side than I am on this side, and when I switch over I'm going to do the exact same thing. Double it up, make sure that nothing burns through. You definitely don't want to mess up your client's car. We're also going to open the door, and that's going to keep most of the slag and junk off the door cards. Well, I'm not a body finisher. I'm not a paint specialist. I can hold my own with that stuff, but I usually, I bow down and leave it to the professionals to take care of stuff like paint work and whatnot. But I do know that it's going to aggravate the absolute crap out of them when they go to spray it, and there's a whole bunch of heavy gouges in there, so I go kind of easy on the sandpaper. 40 grit will take this down in seconds, but 40 grit's going to leave a terrible, terrible finish, and whoever the finisher is not going to be able to get in there and kind of, smooth and clean that out once the windshield is on here, so you got to be kind of mindful of that. I mentioned before I like to brand my product. So this open space right here on the front of these A-pillar gussets will be an excellent location for an MP tag. Perfecto.
Well, I mentioned before that driver comfort is extremely important. If you have an uncomfortable driver or something's just out of place, they're not going to have a good race, and that kind of defeats the purpose of being able to custom tailor a cage and everything else to them. So if they're not comfortable, it's not going to be a good day, and you probably won't get a great recommendation for being the fabricator for them. So yesterday we took a lot of time, and I mean a lot of time, to ensure that the seat placement where the driver was at was exactly where he wanted it to be. The reason why is the interest of saving weight. I'm not putting in adjustable sliders or angles or anything else like that. This seat is going to be static, not adjustable, in the direct position, as light as possible. So this can be a little bit tricky because you have to spend a lot of time with the driver and make sure that everything is a-okay. I mean, you can do things like shim the seat and move it up or down just a little bit. I'll show you how to do that. But you need to make sure that wherever it is that he says go, that's where it's going to be and that's where it's going to stay, and you need to make sure it stays that way. So now we're going to get into moving on to building the seat brackets, as you could probably guess. So I'm going to grab a little bit of steel, measure a billion times if we have to, and that's of course very important to remember. And we're going to get the seat brackets built. Alright, got our Sparco circuit seat. This is a fabricated tube mount or tube end, depending on which one you want to call it, and it's basically a way to basically mount up any tubular section to what you're going into it. So I'm going to slip a bolt into the end here and just kind of place this on here. You get it kind of snug. Alright, now we're going to go place it in the car, get it as close as possible to where we had it before, and then we'll start fabricating everything else. So, fabricated tube mount. We'll place the nut on the end here. Get this one locked down. I'm just going to leave them kind of loose so we have a little bit of maneuverability. Place the other one here. Now this tiny bit of maneuverability that they give us will allow the seat to adjust and move and get tweaked ever so slightly. I mean, literally a fraction of an inch means a couple of degrees of adjustment. So try to give as much room as possible while maintaining safety. What I like to do is just kind of center them in here. Now this section over here kind of interferes with our center console, but we might be able to get around that. I'm just going to place a mount there and see how close we are. Probably shift it or move it over a little bit, maybe. No, that's going to have to be modified. So we'll set our seat placer back in position.
eliminate as much wobble as possible here. Now, yesterday we were fiddling around with getting them set just right. We do have measurements and whatnot to ensure that we get the seat in the correct position. But I do recall I wedged this board in here to give him just a little bit more better placement for his layback position. So I'm going to put this back up in here. The biggest things to remember on this one is we measured where the base sits from the bulkhead here, or at least from the section of the, a good general reference point from the chassis itself to the base of the seat has a certain amount of inches in it. And then of course the layback, the top of the seat to, in this case where I measured to the center of the main hoop, also has a certain measurement. So that's going to place our layback. The boards will place our height. And then of course all we have to do then is just center it in there. So as soon as we get it all set in and centered, we'll get it all the pieces filled in. So I'm going to grab the seat real quick. Absolutely must use a lot of caution here in setting it up. I don't want to scratch the heck out of it. So I'm going to get a general measurement real quick here. See where we land. Alright, layback was measured from roughly the harness position about 4.5 inches to the center of the harness bar, which I have. And the lower position, which also determines the layback, I measure at 16.5 inches. And right now I'm sitting at 17. Now this is going to have to move just a little bit. Well, after getting everything trimmed down and whatnot, it's kind of unfortunate. My first design is not going to work as I had planned. So the reason why is, it may be hard to tell in this angle here, but directly above the bolt here, or the mount, is where the seat mount goes. So you can't slide the tube inside of there, and if you did even trim it down, which I had originally thought, you could probably get the ratchet in there. There's just no room to work in there, and it would compromise the integrity of the mount itself. So I'm actually going to bend up some flat stock here. We'll bend it upward and then mount directly to here, and then we'll run our tube and bracing back and forth on that. So it looks like I need a 3¼ inch height off the brake plus 2 inches. So I'm going to get that measured up real quick, bent up, and then we'll get fabricating on this bracket. The same situation happened on the other side as well, and there's even more or even less access to the bolt over there. So I'm going to get that one measured out as well, and then we'll get back to fabbing on this to box it all and finish it all up. Alright, this is a pretty easy bracket. Just get that kind of set in place real quick. Nice and easy like. We got just a little bit of wiggle room here. Just to make sure that it goes in correctly. Now I'm going to absolutely double check my measurements again to ensure that the seat is completely squared and that it has not moved. The layback is correct still. And our general seat position is absolutely still correct. Now, we're good to go. Now, very, very important that this does not move. So you can only put a couple of tacks down on here as well because you don't want to burn the seat. So we'll put on just enough to hold it in place. Okay, that essentially is one mount in. I'm going to go do the other side real quick. Well, you can see it's really, really tight inside of here, and this is much more difficult to reach. But I don't want to burn the seat, and I don't want to take any chances on that. So what I'm going to do is mark mark the tube to the bracket. We should get very close here. So to actually mount these together, I use some 5/8 OD 120 wall DOM. Just gonna tack them in here. And these are just little tack welds to get them set in the right spot. They'll allow me to get it all positioned in there later. Alright, so I'm going to let those cool down for just a moment, and then we'll run back and start tacking it all together. I have to pull it all apart, of course, to to ensure that it doesn't burn the crap out of the seat. So as soon as that gets cooled down, we'll lay down some good welds on there and take it out and weld it all together completely. Okay, so for the left side, we're going to start with the same tubing that we used on the right. I'm just going to get a solid tack in there, just to start out with. Now I did, of course, pull the center console to make installation and working with this just a little bit easier. We're going to go very easy on this because, again, we don't want to burn the seat, and this is very, very close. Just a simple, very solid tack weld will do the job. This is, of course, one of the really nice things about using a TIG is control. Now, the only general cautions you really need to be made aware of are the amount of distortion each weld can have. So if you've only tacked on one side, when you start tacking the other side, it'll want to kind of pull and tweak it just a little bit. So you want to just do little tacks on the opposite sides in as many corners as possible, allowing it to cool down each time. That way the amount of distortion is minimized, and then you can go back and buzz it all together. Alright, one more piece before I get started on the other side, and this is just a little reinforcement. Not a bad looking piece. So I'm gonna let this cool down real quick, and then we're gonna jump on the other side again. So with all the welding complete, I'm just gonna do some little trimming and kind of do some cleanup work here, make these tubes look, not so random, I guess, if you will. I got a couple of pieces here. Of course, this one is gonna have to be trimmed down in order to fit underneath the console, and I'm gonna trim this tube down a little bit.
This side here, I want to trim this tube down a little bit, and I'd like to give these two some angles to kind of match that really nice style that we have going on up top and or at the bottom here. So I'm just going to grip the cutoff wheel on the end of the grinder, kind of trim these down a little bit here. Sweet, everything looks like it lines up beautifully. Now I did leave the seat just a little bit loose for the purpose of getting everything in here, thinking it would ease it, because sometimes, I mean, even though you try not to let it warp and distort, you know, sometimes it's just gonna. There's a lot of things that control that, but you know, every now and again it happens. It's kind of unfortunate, but you know, it's all part of the game. With these holes and everything lines up just perfectly. So looks like I did it right. All right, I'm gonna get this tightened down here, and now we can move on to the door bars. So let's get on to the door bars here. There's a few different designs that you can incorporate and then are allowable in the world of GTA and RTA and many other local sanctions. They usually just kind of take off from GTA. The most common design you see is the X-brace. So it'll start up top and it'll go down to the bottom in a diagonal form, and then you'll see another brace or another tube that'll come off of here, weld to the primary, and then another one that takes off and welds down there, so you actually get the S. So it's two diagonal braces crossed, obviously three different tubes. That's one design. The other one is the curved design, which I use the most often. And the curved design will come down and instead of cutting the tubes and welding them all together and whatnot, you'll actually just put a bend in it and then kick the top tube up, and then the same one goes at the bottom. So that's the design I'm going to use. It's the one I use most common. There is a safety feature involved in that, which was actually by request and will be added to this. And that is the ability to kick the tubes outward a little bit, because it's, as I mentioned earlier, it's kind of difficult to unbend a bend. So the impact or the side loading from an impact would go more into the bend. The bend would actually try to break outward, which is a lot more difficult than concaving or actually pressing into instead of bracing and whatnot. So that's the design we're going to use. So let's start with what we know. We definitely know the design. I do know that I want a higher upper tube, and I know that it's going to be somewhere around this line here, because we still have to consider egress, which is a fancy way of saying get the hell out of the car when it's on fire. Emergency escape. So have to consider egress. There's not a lot of space in here to actually work with, so a high bar is going to be extremely difficult to get out of when the time comes, if you ever have to emergency egress. So I'm going to keep it relatively low, and I'm going to run on this line here, which I've already measured up. Comes out to 10 inches. So I'm going to make this 10-inch mark my center line. So that's going to be still, not too much higher than the seat. It'll be relatively easy to get over, and of course an emergency egress still possible. So what I do not know is the angles that I need to bend everything at to actually make this. Now I can look at this and say that my lower tube needs to be about this high with the other tube stacked on top of it. It's going to be about 20 degrees, but we're going to double check and measure that out anyway. I do know where it needs to land, which I have it marked here on the tape. This was during the driver's fit check. His elbow actually runs right about here, so when he's turning and whatnot, he's not going to be elbowing and smacking the tubes. So they need to be a little bit lower than the seat, and they need to be in this general area that I have marked out with the tape here. So I'm just going to take a couple of boards here and just kind of stick them in there, because this will help me set everything up and whatnot and measure out my angles. I also use the cheater with a piece of 1 1/4 inch in the middle of it, and that helps me slide this and move it in whatever direction while I'm lining it up with the back. So I'm just going to line it up with the lower section of the main hoop. Just
kind of set it up there. And I'm going to get my bend right here in that area. And I'm going to take my, another bend. This is just a throwaway that I use for scraps and whatnot. I'm going to place it on top of that where it's eventually going to be. Kind of give it a semi-decent lineup, shooting towards the rear there, and say, okay, yes, I like this height, or no, I don't. So I do like this height where it's sitting at, actually. So I'm going to, lucky enough on the first try, I got the boards to sit right where they need to be. So since I don't know how long the tube needs to be to my first bend, I'm just going to take a measure. Measure a little past the main hoop, right up to the beginning of the bend on the cheater bar. Looks like about 15 inches. So 15 inches worth of tubing. Now we'll measure the angle, roughly where it needs to be. This is, look at that, 20 degrees. Just like that. Yeah, I've been doing this for a while. So I'm going to take this other tube and we're going to set it up top, and I'm going to aim for the top there where I actually need it to mate up. And since I do not know that angle, that's at about 40 degrees. And then we need to take a kind of another measure here, and I'm going to aim for that center line. Now this is kind of eyeballing here, and there's a reason why. And it looks like that's about roughly 10 degrees. So I'm going to start with about 40 or 45 degrees, do a fit check in here, and then find out where that's going to be at. So I know that the start of this bend, which is actually marked out on this tube, luckily enough, you can barely see it. So I'm going to kind of use this as my cheater. And I'm going to aim for the spot where I want to weld it. And it looks like to the start of that bend is about, we'll go 18, 19. I'm going to go 20 just to be on the safe side, because that's a pretty hefty notch that we have to run out of that one. So we got the measurements of the tubes. We know about how long they need to be. This one, 2 feet plus the 15 inches. Each one, I'm going to say that each one needs to be we'll make them about 40, 48, somewhere in there. We'll cut them about that long, and then we'll get them bent up and slapped in here real quick. This should be pretty easy to do. Well, I got lucky a couple of times here, actually. First one obviously being with the measurements there. I got the 20 degrees. I guessed that right, which is a pretty good educated guess, actually. But, hey, I got that right. That was cool. And then everything lined up on the first try with those boards, and now this. I looked in the cut file, and I know my lower tubes are going to calculate to roughly 41 inches of material that I need, and I found this piece right here that's already at 82 inches, so all I got to do is make one cut and cut it in half. That's about 20 right there. See how it looks. This is just general placement here. Looking pretty good. Let's see. Yeah, 20 ought to do it. So by the time I actually get it back up, trimmed and notched and whatnot, it's going to be a little higher than directly down at the base at the rocket boxes. So looks like 20 degrees is the magic number. So I'm going to prep these and get them notched up. And that shouldn't take too much effort. Yeah, this should be pretty easy. I'm going to get these notched up real quick and get the top tube. Now this form of notching is actually extremely difficult to do, and it's you need to be very, very particular with it, because your face line is actually going to be on a kind of a angle, or it's not going to be completely dead on where it's supposed to be. So you need to make a reference line here of about where the depth of the throat's going to be. And then your face line, which you have to kind of eyeball and roughly get the angle correct, be about there. So 1/3 tube diameter. We're actually going to cut this out this way to kind of reference about where it needs to be. So I'm going to turn the tube on its side, and we'll mark it out again so I can get the correct cut. So one thing I didn't mention earlier, slipped my mind, but as far as the main hoop placement is concerned, it does have a certain degree of layback, and you'll notice that if you try to just place the tube in here and set it up notched in there and then try to slide it down, that it gets stuck over on that side. The reason why is because the tube has to fit around the other tubes in order to, for the correct notch. So the main hoop does have a slight layback to it, so you start the tube from up top and you try to slide it down as level as possible to lay into where it needs to. Otherwise you won't be able to get the tube in. So I've been working on these notches, and I have just a tiny bit more to go until this door bar fits perfect and it's ready. Alright, so we need to be able to weld the tube 360 degrees all the way around, and I refuse to let the tubes actually contact the chassis. I think that's kind of tacky, so I'm going to put a spacer in there. These notches are pretty tightly fit right now. Give them a couple thunks of encouragement. And of course, double check the back. Make sure it's still accessible. I'm going to use this piece of 1/8" steel to set my gap. And we should be good to weld. I just did a really quick 40, 45. I think it was about 43.5, somewhere in there. I'm just going to do a quick fit check here to see how close I am. We're within the ballpark still. I can give it another 5 degrees. So I'm going to put this back in the bender real quick and set it back up on my mark. And I'm gonna end up kicking it up to 50 degrees. All right, I got the door bars completely fitted up, and of course I didn't focus a whole lot on the welding there. You've seen me weld a whole bunch throughout this video, so I mean a little bit less is not going to hurt being able to see. But it is very tricky to get inside of some of these places and whatnot, and there has to be a lot of focus for me to get that. So that's why I didn't put most of it in. But the door bars are completely installed. Now you can definitely see at this one that I went high in the rear just like I wanted to before, went low, have it set up. The only spot that is not set up the exact same spot is over here in the corner where I had my 10" center line. I actually dropped it down a little bit, and the reason why is because this window has to be able to roll down. I do consider it slightly tacky if you have to open your door to roll down the window because the crank will hit the door bar. Now also, when I set the seat back up in here, I realized that at the 10" mark it was just a little bit high, so to assist in egress a little bit more, the bar, I wanted to bring it just a little bit lower anyway, so it kind of worked out greatly in that one. Now one thing that you can definitely see is that the bars have an outward bend to them, and this is the best way I can demonstrate this angle. But the problem that we run into is when it does have the outward angle, we're going to have to end up trimming the door a little bit. And you can see here where it starts to hit. Now it does specify in the street class of the RTA and GTA rule book that all door cards, dash, center console, all plastics, OEM controls components, they need to be in place and in the car and installed and functioning.
Now, you are permitted to make whatever necessary modifications, and I mean absolutely necessary modifications to facilitate the installation of the roll cage. So, since we can't close the door, it is absolutely necessary that we trim back that door card to allow the door bars to actually slip in there and we can close the door. So, pretty simple. Look at that. Perfect accessory for a perfect race car. We got an inside net, sometimes known as a driver's net. We're going to run this across here to see about where we can fit it up. So let's get started on that. Alright, so I'm going to start by trying to figure out where I'm going to mount everything up here. And we'll get to placement and how we decide all that in a moment. But definitely need to go over the top portion of the main hoop here. Get that wrapped around and kind of just loosely set in place, you know. Just for the purposes of mocking everything up here. We'll figure out everything in just a moment. And now we got to find a spot for the front of it to reach. And you know, there's not a whole lot of space here, or not really anything you can technically mount it to, but behind the dash there is. So, according to the rule book for the class that this car is racing in, everything on the dash needs to be, you know, kept in place, all the panels, everything else like that, unless you need to modify them to facilitate the installation of certain components. So, actually, I'm looking at the dash clock here, and that seems to be the perfect place to actually run this net, or the front mounting portion of it, because right behind the dash there is a dash bar. It's a factory dash bar, and I think that'll be a great tie-in point for the front of this net. So I'm gonna get that clock out of there real quick. Have to kind of delicately pull this apart here. Unplug that. Okay. Just a few screws here on the back side. Get these out of the way. I will pop that panel back on there. Alright, so the front of this, got a couple of straps, and this is going to be pretty difficult to get in there, but I'm going to feed it through and try very hard not to let it smash any of the components inside of there. It's a very, very tight fit. Hopefully I can reach everything. Let's see, there's part of it. Now this is going to have to be tied, you know, and cinched down a little bit better once it gets behind there, but I do have the restrainer, the band, the clip here. I have this in the right spot for the belt or the buckle itself to stick out through the dash clock, so I'm just going to use what limited access I have here and try to tighten this up the best I can. At least get it started, and then I'll run it back up in there and cinch it down. It would absolutely help out tremendously if you knew somebody with small hands. Get them to pull it in for you. There we go. And we are strapped in. So I'm just going to leave the slack just kind of sitting behind here. Should be okay there. We're tied on tightly to the dash bar. So let's put our panel back on. Voila. Alright, specifically in the rule book it states that the lower section of the net should pass horizontally about the level of the driver's shoulders. So our driver actually fits beautifully with the seat, and his shoulders are right about where the shoulder bolsters are supposed to go, so we can run that directly across. Now if you notice over here, there's absolutely nothing for us to tie onto, so this is quite a lot of excess on here, so I'm actually going to tie into the rear strut bar that we fabricated earlier.
So we're just going to loop this around and make sure that the straps don't twist. That's not allowed. Send this loop through, back up through the buckle. I'm going to cinch that down pretty tight. I want it nice and tight, and we're going to pull it a little bit closer toward the driver. That ought to do it. We'll just pay out a little bit of slack here so we can get this second portion through. You're basically routing it back through to cinch it down tightly. This is the same with harnesses as well. So we'll get that as tightly fit as possible. You want to pull up on the loop as it's already been fed through. Get that as tight as you can. Grab hold, also as tight as you can, and as quickly as you can, give it a good tug. Now it's in. The center strap is actually a breeze. And feed this around, kind of get it adjusted correctly. Hold tightly. Yeah, that looks about right. So again, making sure that the straps are not twisted. Feed it through. Give ourselves some slack here, just to be able to pay this through. All right. Now again, we'll pull the loop snug. After that, it's just a smart tug. Get it nice and snug. There's our center section. So this can be, obviously it moves a little bit. We're actually going to put a little belt stay or a strap stay on there so it doesn't move around. So that's actually listed in the SCCA portion of the book. So now we'll move on to the top one, which we had loosely fitted before. Make our adjustment here. That's a little bit too much. Back it off a little bit. And that should be a good wrap around there. So again, I want to kind of pull it tight here and make sure that everything lines up where it's supposed to and correctly. So again, one more time, making sure that it doesn't twist. Start feeding it through the buckle. No twist. A little bit of slack. Need just a little bit more slack on there. There we go. Now we can feed it back. Perfect. So slack back on it. Nice and snug. Bingo. So now we just got to get it aligned real quick. I'm just going to work on the alignment here a little bit. And we're going to have to put some strap stays or belt stays in there to make sure that it doesn't move. Now you notice if you move it, it kind of loosens up and it gets a little sloppy. So the idea is to keep the belts in place in the correct position in which we installed it for that nice tight fit. So I'm going to go bend up some 5/16 rod, and we're going to bend it just enough to get and hold the strap in place, and we'll just tack those in there, pull the net back out, fully weld it. Job is done. Bending up some belt stays is actually very easy to do. Just take some 5/16 rod, round stock, bar stock, whatever you want to call it. Stick it in the vise. 1/2. I'm going to leave just about a finger gap at the bottom there. There's nothing like really specific about this. It says you have to have it a certain way, but yeah, that looks good. Works well enough. Now we'll just cut that off even and we got a belt stay.
Don't require a whole lot to get to stay. We're just going to toss a couple of tacks in real quick and make sure we maintain the alignment of the net. Just a couple of good tacks will hold it. Decisions. Should I have it on the back side? Should I have it on top? Yeah. Let's see. Yeah. Maybe I'll put it on the back. That should look okay. This last one ought to be easy. Just throw that. Oh, right about there, sure. Why not? So I'm just gonna take the net down real quick so I don't set everything on fire while I weld it. We'll just do the opposite of install to uninstall. And you want to attempt to not move your buckle. So make sure that you actually pull the strap out itself without moving the buckle. This will make it a lot easier to reinstall later. Sitting here looking at this while I'm waiting on everything to cool down here, and I'm like, you know what? I can make this look a little bit nicer than just a hole in the trim panel. So what I did, I gutted the clock, and I'm gonna stick that back in there, and that ought to look a lot better on the reveal. In fact, it'll look pretty clean. So these clocks aren't anything particularly fancy or whatever. They don't really read in Japanese or anything. So I'm going to put these screws back in. If he ever wants a replacement clock, I kept the guts. Alright, let's stick this back in here. See. Oh. Ooh, that looks a lot nicer, and that doesn't fall back in too easily either. So, yeah, good decision. I like that one. So everything should be pretty cool now. We'll put the side net back up in there and then hook it all up, get the final adjustments. This one's done. Pretty textbook. Okay, now we're going to add some rear bracing. And I mean, there's a few different terms for these. Some people call them rear upwards, some of them call them rear door bars, other people just call them more triangulation. I mean, there's a dozen names that people use to refer to these bars, but it's going to stretch from the lower point where the lower door bar meets to the back here, right at the strut tower, as close to it as I can get. So in order to get it in there at this angle, I'm going to need to trim off some more of this sheet metal. So really simple to do. Real quick, we'll just take a measurement. It looks like we have a total length about 34.5 inches. So I'll go cut a 34.5 inch tube and get notching. That was the very last weld. That weld right there marks the completion of all of the fabrication needed to build a global time attack roll cage. It's finished. Finally, it's finished.
Now we got it all buttoned up and it's time to finish off. So the final thing that we need to do here after this beautiful cage has been made is we need to be able to certify it. And the way that we're going to have it certified is by drilling a whole bunch of little holes into it. And while that sounds crazy, well, the reason for drilling all the holes is all the tubes need to be inspected. And per the rules, we need to put a 3/16 inch hole in every single tube, or in every single main tube. Now I put them in all the tubes just, for the sake of in case, one sanctions rule book is slightly different than the other. Some would say all the tubes, some would say main tubes, some would say primary tubes, some would say one hole. So the majority of them will tell me all holes, or all tubes, all holes. But the most important thing is they need to go in a non-critical area. So do not put a hole right at the end right next to a weld. Do not put a hole in the middle of a bend. Do not put a hole, in areas where a load is being bared, or it's too close to a heat affected zone or anything like that of a weld. So personally, with all of my holes, I like to kind of hide them actually. You got to know where they are, and we got to have a good spot to put them. But I don't like them to be exceptionally visible. So if they're you're taking nice pics or whatever the case is, like the photo gallery that we have available, I don't want all the holes to be seen. So what I'm going to do is pick a few different locations. Most of them are on the bottom sides or underneath, and they're typically everything's away from an area of which we can isn't going to be accessed. So. Now, one area that I absolutely do put the holes in pretty much the exact same spot over and over again is my main hoop. I usually just stick one in the back. Now, I normally follow and chase everything around with a marker first, just in case I decide I want to change my mind, then I can go erase the marker, and I can't weld the hole back up and then grind it down or whatever, so I can erase the marker if I don't like it.
Alright, so let's take a look at the noggin bar here. There are a couple of different places that we could put it in. We don't necessarily have to have a hole in it, but we do have to have one in the windshield bar up top. So normally I put the hole in the windshield bar right at the center of it, but since there is a bend right at the center of it, and there's already a hook right here, I'm just going to move it a little off center, and I'm going to put the hole right just outside of that bend. Now the only question is, do you put it in the face of it here, or do you put it down below, or maybe even put it from the front side? So that's entirely up to you to decide which way you want to go with it. In this case, I think I'm actually going to put it on the front side to where it's a little less visible. And then on the noggin bar, I'm actually going to go somewhere up in this area, kind of to match how the main hoop was, and I can easily access it from here. The gussets themselves, they don't necessarily require any type of holes or verification into them, so we're not going to drill them. But later on down the road, if the tech official says we do absolutely need to put holes, inspection holes in the gussets themselves, or in these corner gussets, we'll put one right here, and we'll do the same thing on the other side. But for right now, we're just going to leave these alone. These do not really require a hole in them, but later on down the road, if we need to put one in, we'll put one in. Now on the door bars, I typically like to go just on the insides. And this is nothing really fancy, just a few inches away from where the weld is. We'll just toss one in there, one in there. We'll do the exact same thing on the other side. That's pretty easy. And also on the diagonal bars, there's lots of space underneath here. So then anywhere between 5 and 7 inches, we'll put one on the bottom. We'll do the exact same thing on the opposite side, just so it's completely mirrored and easy to remember where they're at. Now these tubes here, we don't really need a whole lot of fanciness or anything like that to throw in a hole in any kind of place. I'm just going to take the underside 5 to 7 inches away from the weld itself. One there, one there. Now we definitely can't put one on the underside of here, so actually just right as we open the door, I'm going to toss one just kind of up and out of the way. Now this tube doesn't necessarily need a hole in it, neither does this one, but we're going to add them just to be on the safe side. Now the door bars were already done, so we don't need any additional holes in them, but the A-pillar bar up front, we do. So normally I would sneak one in behind the AC vents if the AC vents were going back in, but in this one I'm just going to kind of
just sneak it right underneath.
And then just keep it out of the way. Again, I want to put, for the windshield bar, I want that one up there. So it's just kind of, yeah, the tech official can get in here, I can get in there with the drill, and it's not in any one of these critical areas, and it's not visible really any other way. So it's going to be kind of hard to see from up top here, and you know, it kind of stays out of the way. So we'll definitely,
just like I said before, same thing on the opposite side. So 5 to 7 inches away from our welded area. Same thing on the diagonal of the main hoop diagonal bar. And then we're going to sneak one right underneath. Just a little one. So that pretty much knocks out every single tube. Just got to get to drilling and get all of these in here. And then I got to let the customer know where every single hole is, so that way he can go and show all the tech officials in case they need to know. So let me grab my 3/16 drill and we're on our way. Well, that's about as good as it gets. That's a wrap. Well, what'd you think? Well, I hope it was good. In the comments below, you can tell me all about it. If you got any questions, again, of course, drop me a line and let me know what's going on. I'll do my best to answer you. I'm waiting for that magical moment right now where the client's going to come over here and pick up his car and roll it on out of here. We're going to catch up on it later on, and hopefully we'll get you some really awesome progress updates, maybe a couple of track runs, whatever the case is. I'll do my best to keep that up there. Hope you made it all the way through to the end of the video. Sorry it was really long, but then again, you can't always explain how to do things in just a couple of minutes. So I appreciate your patience. Thanks again for watching. That's going to wrap it up for this episode of the Fabricator series. I will see you guys on the next project. Thank you.